you can implement the stack here. Of course you can use the concept of arrays. Of course you can concept of the linked list. So how you need to implement using arrays, we'll try to write the code everything, and also for the linked list both will do. Hello everyone, welcome to our channel CSE Gurus. Because first I want to implement with respect to array. I'm writing the code step by step. You can see and get ready with the compiler. You also can execute and check the output. Yeah, initially how to start with here. Here anyway we are starting with stack, which is using an array. First of all I want to take a stack as a global array. Why? Because you are making some methods. For each method, whatever the updates you want to do, if maybe it is a push operation, pop operation, whatever it may be, it has to update in only one simple array, which is a stack array. So that's why I'll take a global array. Of course might be I'll try to write hash include stdio.h, the basic header file, which is used for like print to read to understand this printf and scanf functions, which are defined in the stdio.h. Now I'll take a stack array. So let me take like stack of something, like stack of might be 100, means I declared an array which is a stack of 100, which you can make it. And of course in input you might not take 100. Okay, you can take like this, like int n. What is n? Is equals to, like this you can give int n equals to 5, like this, and according to that you can make the values. That is also absolutely fine. So I'll take a global variable n equals 5, means I want to take maximum of 5 elements in the stack. Now I want to write the code here, void main. Now I want to write a menu driven function where user wants to give the option, so that I have to execute. So int choice, okay, I'll ask the user printf what he wants to do according to the stack operation. Now I want to write here enter your choice. So the choices are here. What are the operations? I'll keep it all. I'll write initially. 1 for push operation, pushing the elements into the stack. 2 for pop. 3 for display, what are there in the stack, I want to display them. 4 for what is the top of the stack, that is also I want to print it, what is the top element. And of course I want to write 2 more. The 2 more are, which is the 5th one, checking is that stack is empty. That's what I want to check it out. 6th option is that stack is full. So of course 7 is, which is exit, to come out of the process. So like this I need to take the functions first. Now I want to write a scanf where the user will give options here, %d comma and %choice. Now according to the choice we need to go for the switch case, where which option you want to write, switch the ch. Yeah, we have cases. I'll write all the cases here. Case 1, case 2, case 3, case 4, case 5, case 6 and case 7. Now anyway case 7, which is exit of 0, which you need to come out of that. Anyway, that I'll explain why we are writing this. Now first thing, case 1, which is for push operation. When you give push, means you have to insert an element. So I have to give first the element to be pushed into the stack. Enter the element to push. Yes, I'm reading it from the user. %ld scanf %ld comma, I'll give the value. Okay, I'll try to write as val, which is the value. Anyway, the variable value to also to be declared here, the variable. And then once you give the value, yes, push operation to be executed, I'll write push of given value and execute it, and then break statement. Now I'll try to write this function, push function, with respect to the value, which has to push the value simply. Yeah, I'll write here void push with respect to the value int, the value something like x I have taken. That is what is the val value, which is x value. Now what are the things you need to do first when you push it? I'll try to write it. The first thing, yeah, it will be like this. We have a stack, I'm writing, so 0 1 2 3 4 like this. Now what is the top value initially? Stack is empty anyway. How can I say that stack is empty? Let us suppose if I give a value here 10, top will become 0, right? Index I'm talking. So but if I delete this one, if I delete this one, the stack is empty, means the top has to go to the below index, which is -1. Now I can say if top equals to -1, stack is empty. That is also the initialization I have to do first. Anyway, I'll do it on the top. Int top is equals to -1 initially, means initially stack is empty. Of course we know top equals to n-1 means stack is full. That also we'll see. Yeah, first I'll push it on the stack. So how to push it first? So first of all, you can write like this. Either first, let us suppose you have to do top equals minus means you have to make top plus plus, then stack of top is equals to x. What happens here? If I write like this, what happens? What is top value initially? -1. Top plus plus, -1 will become 0. Now stack of 0, what is stack of 0? Nothing. X value you have to, for example, stack of 0 10 you inserted. Now next time if you come, again you want to execute push function. Top plus plus, top will become 0, will become 1. So here, so what is stack of top? Let us suppose 20 will be inserted. Next time, so stack of 2, top value will become 2, so 30 might be. Next top value is 3, 40. Next top value is 4, so 50. Now you see what is the stack size? I have given n equals to 5. That means you can insert only maximum of 5 elements here. So I inserted 5 elements. Now I need to say, if I enter the next element, yes, you have to say stack is full. The stack is full. How can I say that? See, what is top value? 4, right? Now you need to check it out. If the top is 4 and n is 5, means if top is equals to n-1, right? So it starts from 0 up to n-1. So what is top? 4. What is n-1? 5 minus 1, 4. So if both are equal, then can I say your stack is full? That means you cannot insert the elements. So that is a condition that first you need to check it out. So for that I'll write here if condition. If top is double equals to n-1 means yes, stack is full. I want to print it. Stack is full. Else if it is not, means yes, you can simply insert. Else means you have to write these 2 lines. And one more thing, clearly remember here, can I make it as a one statement? Yes, we can make it as a one statement. Instead of writing top plus plus here, I can write here stack of plus plus top. This is fine. This is fine, you can write it. But remember the very important point, don't write stack of top plus plus, where this will give a wrong answer. Why? Because it's a post increment. That's why what is top initial value? Let us suppose -1. It wants to insert in the stack of -1, whatever it may be the value. Actually our intention is first increase the top value, then only you insert. But this is a wrong notation in the line number 31, where it is doing first inserting at the top, then increasing the top value, which is wrong. First our intention is top has to be incremented. That means you can write plus plus top. This will give the correct answer. If you still confused, you write that top plus plus before this line, then it is correct. So remember this point, you cannot write stack of top plus plus here, which is a wrong one. So I think this is fine. If top is equals to -1, printf stack is full, else you insert it. That's it, will be inserted. Top is incremented like this and the value went there. And then I'll try to go for pop operation also. directly pop operation, where for pop operation I don't want any values as a parameter. Pop then break. Now you can see what pop will give here. We'll try to make it. I'll try to write here void pop. When you have elements like this, so what is top value 4? What is the value here? 50 has to be deleted, means you simply make top minus minus. So the top will come here, means we have only in the stack only these values to be considered. So like this. So simply I can write here, first thing I can write here top minus minus, then yeah, before that I want to print this what is deleted on the top of the stack. So I'll try to write %d deleted, where which is stack of top. First I want to print what I want to delete, then top minus minus. Anyway, top will come to the next point. Now here also one more thing you remember. So now top is actually in position 4. Now you deleted this 50. Top is here 3. Next you deleted with pop. Top is at 2. Next you deleted this, top is at 1. Next you deleted this, top is at 10. 10. It is also deleted. Yes, your top is at -1. Now when top is at -1, what is the meaning? Stack is empty. Can you delete here? No, right? That condition I'll write. If top is equals to -1 means what? Yes, stack is empty. You cannot delete, right? There is no element to delete actually. So stack is empty. So like this you can write. Else of course you can go for it. %ld deleted, and you can write top -1. Yes, I'm making it in the closing braces. So this is pop operation. You can easily make it like this, pop operation. Now once the pop operation is done, we'll go for display. Let us see how the display will be. Anyway, I want to write case 3, which is the display part. Display then break. So what is this display? I want to display at a current instance what are the elements in the stack. So void display. I want to display. See, I'm not retrieving actually. Remember the points I told you, like you can only retrieve the top element. Just I want to display what are they are. I'm not retrieving actually. I just want to display there what is there in order for our understanding. Yeah, I'll write for I starts from where it needs to start actually. I starts from top, where it needs to go. Let us suppose my elements are from here. So let us suppose I have elements like this 30, 40. Now why my top is here? Why? Because the last top of the element is this, and I need to start from this and I need to come to this position. So I'll write like this. Your top value starts from, I starts from your top. I has to go till 0. I minus minus. I want to print them. Printf %ld, of course /n to make it in the next line, the next value. It's not stack of top, it's stack of I, right? It's stack of I. You can print it. Now one more thing, here also you can represent like what if the stack is full, you can print it. What if it is stack is empty? So that is also I want to write. If, what is the condition for empty? If top is equals to -1, yes, printf what? Stack is empty or no elements to display, it's up to you. Of course else part you can write like this. So else you need to go for it, and you can make it this for loop to be executed to display every element. Now anyway, we'll try to make it the remaining also. First we'll execute whether we'll get these things or not. After that we'll write the remaining things. Let us see here. Yes, perfectly fine. We have written. Enter your choice. Let us see the display initially. Stack is empty. No elements are given. I want to push the element. Yeah, one more thing we forgot actually. See, why the compiler. One more time I am going like this. You can see what is that we missed here. If I see something like, anyway, enter the element 1, push, enter the element 2, push. If I write 20, you can see it is taking and process return. Why? That is what we missed here. We didn't write this printf and switch in the while loop. So we need to write in the while loop, right? So this is what to iterate every time. I'll write here while 1. So we have written while 1 so that the options you can take until you give the option 7. That is why we have written exit here. So we'll close this while loop here so that you can see now. Yeah. So I'll give the display part initially. Yes, stack is empty. Again it is asking. You can see that's what we have written for while 1. Means that loop will be executed infinite times, like until we go for exit, that is case 7. Now you can see the next one. Stack is empty initially. I want to push the element, option 1. Enter the element. I'll enter 10. Then if you see the display part, yes, 10 is there in the stack. Now enter your choice. You can see I'll give again pushing the elements 20. Again I'll push the element 30. Again I will push the element 40. Now you see the display part. See 40, 30, 20, 10. So which is recently has to be there in the top of the stack. So we are printing like this. Now we want to enter one more. Let us suppose I want to enter 50. So now you can see the display part. Yes, absolutely fine. But what is the size of the stack, which can only take 5 elements, right? Now I want to enter one more element, 60. Will it take? Let us see. See, stack is full. It is saying it's not able to take 60 because stack is full. So that is what you can see. So the size of the stack, we have taken n value as 5. We can only insert 5 elements here. So that's why stack is full. Now let us suppose I want to go for pop. Which element has to be deleted? 50. You can see the display part here. 50 is deleted. You can see the display part is 40, 30, 20, 10. You want to pop it again? Yes, option 2. 40 deleted. You can see the display. No, you want to pop it again? Yes. So 30 deleted. The display is 10, 20. 1. If I give, let us suppose I want to push it 40. Yes, why not? You can see the display like this. Of course I want to pop it again. 40 will be deleted. I want to pop it again. 20. I want to pop it again. 10 is deleted. Now you see this stack is empty. Still you want to pop it. Yes, it says stack is empty. So like this it will display. So till now we executed successfully, and also we'll see the next part, like the next option. What is it? Top. What is the top element? Top element at a particular instance. So which has to return some value, right? Which has to return the value. Let us suppose I will write returning printf %ld. What is the top value? Okay. So I'll try to write a function called instead of top. Top is a variable I have taken. Top element. I'll take the function ms top element, which in turn returns the top element. What if the stack is empty? If the stack is empty, it has to return -1. So something like whatever, some value we'll take other than the given values we have taken. Of course we'll print stack is empty and we'll return -1 like this. So that is what I'll write here. Let us suppose here it is returning something, that's why int top element. So now you can see the first condition, if top equals -1, simply we'll print, what is it? I'll try to write it, printf stack is empty. Of course we need to return, so that's why return -1. Now else part. So you simply, what you need to return? Else part, you have to simply return what is stack of top. Direct answer, nothing much to do with this. Whatever is the top of the stack, it will be returned. Anyway, I'll try to write the remaining two functions also. Is empty and is full. printf %ld. So this is a boolean function which is empty and is full, which returns 1 or 0. 1 for yes it is empty, 0 for it's not empty. So I'll write here printf. Yeah, one thing we missed to write here, break. That is also missed here. Remember clearly, is empty means true. So then returns 1, not 0. Remember, is full is a function I want to write, where this also, if it is full, then it returns 1. Very simple functions we can write, not much difficult. So I'll write int is empty is your stack. You can see, I'll try to write the code here. What is the condition for empty? Top equals to -1. Yes, you have to return, yes it is empty, that's why you have to return 1, not 0. Remember, is empty means true, yes return 1, else is empty will become return 0. So what about is full? Definitely reverse, right? Like I want to write it. You can see int is full function. So if, what is this full condition? If top is equals to n-1, yes it is full. Okay, so what you need to return, you want to return true, return 1, else return 0. Now this is what you can write, and let us see whether we have written perfectly, any errors, anything. We'll try to execute the entire part. Yeah, now we'll see the execution part. So initially the display, yes stack is empty. Now I want to go for option 1, 10. What is the display part? You can see element 10. Now you want to check it out. You can check it out initially. Is that empty? Option 5. Yes, it's not empty, so 0 is given. Okay, is that full? Option 6. No, it's not full. It is, you can see. So you give one more element 20. You can give one more element 30. So the display part is 30, 20, 10. Now you give one more element, might be 40, one more element 50. Now actually you have given 5 values, the stack is full. You see option 6, is that full? Yes, you can see. So that's why you cannot insert. If it is 1, returning 1 means you cannot insert. If it returns 0, stack is full, no, then you can insert, right? If it is full, so you cannot insert. Let us try with option 2, pop. 50 deleted. Now how many elements are there in the linked list? I mean, how many elements are there in the stack? 4 only, so it's not full. You can see option 6, yes 0. Yes, you can insert. Okay, and anyway display you can see. So what is the top element? If you want to see, yes 40, which is the top element. You want to pop once again, yes 40 deleted. Now you can see what is the top element, 30. You see the display part also, 30, 30, 20, 10. So still you can pop it, still you can pop it, still you can pop it. Now you see the display part actually empty. How can you know that? You can see option 5, yes returns 1, which is, yes is empty, yes it is empty. So like this you can take each and everything, you can execute like this. And one more thing here, of course 7 for exit. Yes, one more thing here, you can see in this we have written push function. We checked here as if top equals to n-1, stack is full, but here we have written function, right? Is full function. So that also you can write. What is full is returning? It returns 1 whenever it is full. So you can write here. Why should I write top equals -1? You can write here, sorry, not here, here. You can write here instead of top equals -1. If is full means what? If the stack is full, it returns 1, means yes, if condition 1 non-zero, stack is full. So similarly pop also, why should I write top equals -1, which is for stack empty? You write is empty. We already defined a function, that function will be executed. What is empty function? If really it is empty, yes, it prints that stack is empty, else it goes. This is also absolutely fine. You can calling the functions which are defined. So I'll try to execute first, and afterwards I'll give the entire code. I'll show entire code. Okay. Yeah, I'll go for push. Okay, element 10, push element 20, push element 30. Right now, of course, you see the display part. What is the top element? 30. Is this full? No. Is this empty? Option 5. No. Now I want to give 2 more elements, 40, 50. Now it is full, right? Now you check it out. Is it full? Of course, you want to push 1 more element. Will it work out? Let us see. 60. No. Why? Because stack is full. You can see option 6. Yes, it returns 1. Similarly, you can go for popping all the elements. All elements are popped. Here you can see 50, 40, 30, 20, 10 also. Still you can pop it? No. Why? Because option 2 you can see stack is empty. You can see option 5 is really empty. Yes, true. So like this also you can make it. Option 7 for exit. So you can see and you can execute the program. So this is what you can write step by step, the menu driven functions, one by one, how to implement each and everything. This is the program, that stack implementation using arrays. We implemented all the functions and we call them. Of course, if you want to change this n equals 5 into this, you can give that n value, enter n value. According to that you can make the changes. That is also you can make it. So we have done with using arrays, stack implementation using arrays. We'll see stack using linked list in the next video. Thank you.